Okay, again, pause this question if you want to have a go, otherwise continue watching and see what you think. So let's have a quick read. The probability that pause train to work is late on any day is 0.15. Again, it's used our word independent, so we can just multiply probabilities and they're not affected by previous events of other days. So first one, the number of days on which pause train to work is late during 450-day period is denoted by a random variable y. Find the value of a, given that is approximately 1/6. Okay, so let's first of all write this down. What can we do here? First of all, what kind of distribution is it? Now, first of all, we know that probability that it's late is 0.15, and we've got a period of n equals 450 days. So you could say that we're calling y, the variable, that y, treated as a distribution of binomial, where there's 450 attempts, and the chance of success, well, in this case where it's late, is going to be 0.15. That's a massive number, and what we can do now, so you're going to mark for writing this, and then you can say we can approximate to normal. So by doing that, again you get marks for this, you can say y Trudeau's normal distribution. Now I'm just going to put first of all NP, because this is N and that's P, and then the other one is NP, and you can use Q or 1 minus P. That's success and that's failure. Just put square brackets so it doesn't confuse you. So now I'm going to say y, and if I do my working out on the calculator, you will note that y approximately has a distribution of 67.5. That's the mean, and the variance is going to be 57.375. Okay, so we've got that. Now what we're going to do, we're going to say, now we can just use a calculator. Before we do anything, we're going to say that we want to find, so I'm going to draw this. Always important that you draw the normal distribution. Here's the normal distribution, and on this normal distribution we want that y is greater than some value here, which is we're going to call a. The chances of that happening is 1/6. So probability. So now, once you do that, now you're going to be careful because some calculators use 1/6 is here, and they'll say that it works out the probability of this, so that's 5/6. So I'm just going to throw that out here and say this is 5/6. But one thing that you know for sure, that the one in the middle, mean here, is the average here, or the mu, okay, is 67.5. So this, if you get a value when you put it through your calculator, if you use this probability when you're going to use your calculator and you're going to use inverse probability, if you use 1/6 and you get a value less than 67.5, it's giving you this bottom end. So okay, so it wants you to subtract 1 from it and put in 5/6 instead. So when you get it and you work it out, I'm just going to quickly put in 5/6. So here it goes. So mode 7, number 3 for inverse normal, area is going to be 5/6. Now be careful, it asks for standard deviation, not variance, so square root 57.375. The next information it wants is the mu, which is the mean in this case, 67.5. Press equals, you'll get a value, says here. So A will be, on this one is 74.827, blah blah blah. Now, because it says approximately 1/6, you could just call it 74 or round it to 75. I'm going to round it to 75 because it is the number of times the train is late, so it has to be an integer. So I'm going to say A equals 75. Okay, so it has to be an integer value. Now, done, 3 marks, happy days. Now, in the expansion, this one, in terms of 0.5 to the r and 0.5r, denote those, show that equals that. Okay, now this is, just to put it out there, really, this is not to do with really probability. This is more like knowing how to do your expansions, etc., and run through here. So if you had this number, what you could do is, I'm going to put it here, part 3, yes, actually I'll put part 3 here, part 2, sorry, and then I can put the part 3 probably here. So what you could do is, first of all, you can say that if I wanted something in terms of 0. So if I've got the expansion, yeah, so if I want that, I can do, if I want the expansion 0.15 to the r, I can say that is the same as 50, sorry, because I've got 50 altogether here, 50 terms, chooses r, so put that in brackets to the power r, and that's going to be times by 0.85. That's here, it's going to be 50 minus r. Okay, and if I want C50 and I want to select r plus 1, okay, then that will be 0.15 r plus 1, okay, and this term here is going to be 0.85. Now it's going to be 50 minus r plus 1, which will give me 50 minus the 1 will give me 49, and minus the r, okay, because you're minusing 50 plus 1. Now, obviously we're going to call this, I'm going to just put it here, this is called TR, and I'm going to call this TR plus 1, okay, to show that equals that. Now if you know this, you should know, should I put it? I'll put it here, that when you have the formula n choose r, that is the same as n factorial over r factorial minus n minus r factorial. Put a box around here. Right. If you're not familiar with this, please get yourself familiar with it. So that is the choose button, selection button, and combinations. So with that, knowing that, you're going to struggle on here. So let's have a look here. So the first one, you got to write it. So we need to rewrite that in terms of you got 50 factorial over r factorial divided by 50 minus r factorial. That then gets times by 0.15 to the power r, and that gets times by 0.8 to the power 50 minus r. Okay, and that's going to be all shared by again 50 factorial over we've got 50 there, sorry, so we've got r here, r plus 1 factorial, and 50 minus r plus 1, which is 49 minus r factorial. Okay, and we again going to multiply that by, now this one's going to be 0.15 to the power plus 1, and that's going to be 0.85 to the power 49 minus r. Right, there's going to be quite a bit of cancellations happening here, so we'll use a different colour pen just to show the cancellations. First of all, you can cancel those out. You got r lots there, and you got r plus 50, so you cancel all those, and you were left with just one of those. So you cancel, not that, you shouldn't have cancelled that, but cancel the r out, so you haven't got one left there. And you got 50 lots of there and 49 lots of there, so you can cancel the minuses out, okay, so you can cancel all that out, and you're left with one of those left there, and you got one of these left here, okay. So what you got, and then also you can cancel these factorials out, okay. So that factorial, this one needs a bit more work, so that, I'm just going to write it here, I'm going to rewrite those so that you can see these ones a bit more. So basically when that's there, I can times at the top, so you get r plus 1 factorial, and that's going to be 49 minus r factorial over r factorial, and that's going to be 50 minus r factorial. And what we got here is, that's all cancelled, we've got one of those on top, 0.85 over, we've got one there left, 0.15. Okay. So now r plus 1 factorial, I'm just going to write it here, r plus 1 factorial is the same as r plus 1 times r factorial. So if you got that is the same as that, this will cancel, and only r plus 1 factorial would remain on the top. And similarly, if you look at the bottom, this 50 minus r factorial is the same as 50 minus r times 49 minus r factorial. So if you got that at the bottom and you got that at the top, then this is going to cancel with this. Okay? And you'll end up with, on the top, r plus 1, and the bottom, 50 minus r. Okay? And if you put this in your calculator and just do 0.85 divided by 0.15, you'll get 17 over 3. I'm just keeping an eye on what we need. So that's going to be t over r divided by t r plus 1, and that will be the same as what they want. That's 17 r plus 1 and 3 times 50 minus r. Now that's a bit of a cheeky one because there's quite a bit of working out going on there, but it's going to help you later. So if you don't get this, and don't panic too much, you can still use that for later. And let's see how we'll use this later. So let's have a look. It says here, the number of days on which Paul's train is to work is late during 50-day period, so that's where the 50-day period is coming from. It's modeled by random variable x. Okay. Find the values of r for which that less than equal to that. So you know that so it's over a 50 period time, and you know that if you get the probability, if we did probability of x equals r is less than or equal to probability of x equals r plus 1, and if I divide both by probability x is with r plus 1, so we get probability x minus r divided by x equals r, sorry, over x equals r plus 1 will be less than or equal to, and that divided by itself is 1. Okay, now that probability x equals r is the same as tr, which we had here, and that probability x equals r plus 1 is the same as tr plus 1. So we already done the hard work here. So therefore, you've got 17 over r plus 1 over 3 times 50 minus r, and that's going to be less than or equal to 1. And we need to find the values of r. So if you times that up, we'll expand it out as we're doing it because of the limited space I've got. And at the top I've got 17 r plus 17 is less than or equal to, and times that up, so 1 times 3 times 50 is 150. 3 times minus r is minus 3r, and bring that to one side gives me 20r is less than or equal to, take that to the side, gives me 133. So r is less than or equal to 133 divided by 20, which gives me 6.65. So r is an integer, so let's find the values of r. So r is going to be greater than, so r is going to be greater than or equal to 0, but less than or equal to 6. Okay, r can be 0, 1, 2, 3, 4, 5, or 6. Okay. Yeah, so that's what that is. R is an integer, so how many times the train can be late. Integer value. Okay, last one, 2 marks. Hence, find the most likely number of days on which the train will be late during the 50-day period. Now, most likely days it will be late. So looking at here, you put it through there and work out the probability of each one. And looking on here, so hence find most likely number of days the train will be late on a 50-day period. So looking at those probabilities, I'm going to put you can sub those values in, and you'll note that let's just put the highest number there, 6, probability x equals 6 over probability x equals 7, 6 plus 1 is 7, is going to equal to, just put that what probability I get. So I get 17 open bracket times 7 divided by 3 open bracket 50 minus 6, and that gives me about 0.905. Yeah. If you try, let's just try. So what's it? Find the values of r. Let's try 6. Let's try the 7. So if I put, yeah. So I'm just going to try one more number there. Sorry, go backwards. For one to put 7 there. At the top, I'm going to put 8. Okay, Yeah. So here, the most likely it's going to be late is 6 days. So I'm going to go for 6. So I know the math scheme says 7. I'm a bit confused why it says most likely the number of days the train will be late is 6 days. 7, when I put substitute x equals r equals 7 in there, it can't be 7 anyway. But it seems not, it's gone and rounded it up to 7. Okay, so yeah, you get at least a mark for that, maybe 2. Okay, thank you.